Hi students, in the previous class we have discussed the Carl Pearson's product moment correlation coefficient, and in this class we shall be discussing the properties of Carl Pearson's correlation coefficient. Okay, so let us begin this class with the properties of Carl Pearson's correlation. First property says that the correlation coefficient is a unit free measure. Okay, the correlation coefficient is a unit free measure, means it does not have any units. Okay, so for example there are two variables x and the other variable is y. So if x represents the heights, okay, heights heights of the students, and y represents the weight, okay, weights of the two students, of some students. Then the correlation coefficient, say heights are measured in centimeters and weights are measured in kgs. Okay, so in this case what happens? The r of xy, correlation coefficient of between x and y, is denoted by rxy, and rxy is independent. It is independent of any of the units. So neither centimeters nor kgs or none of their relationships. So it will be unit free, is having no unit. Okay, so it is unit free, no unit. So it is just a number which represents the relationship between x and y. And the property says, it also says that it is lying between, it lies between minus 1 and 1. Okay, it lies between minus 1 and 1. Okay, so consider this number line here. R, the coefficient of correlation, lies between minus 1 and 1. Okay, if r is equal to minus 1, we say it is a perfect negative correlation. If r lies between minus 1 to 0, if it is lying between minus 1 and 0, we say it is a negative correlation. If it is 0, we say there is no correlation. If it is greater than 0 but less than 1, in that case we say it is a positive correlation, not perfect yet. Okay, but if it is equal to 1, the last line, we can say that it is a perfect positive correlation. Okay, then, and one more property is related to change in scale and change in origin. Okay, we shall understand that first. The correlation coefficient or the coefficient of correlation remains invariant under the change of origin and or the change of scale of the variables. Okay, but it is dependent upon the sign of the scale factors. Okay, so let us consider that, say, u and v are the two, x and y are the two variables. Okay, x and y are the two original variables. Now they are being converted to u and v. X is converted to u and y is converted to v. Okay, y is converted to v. Okay, how? By affecting a change in scale and change in origin. Okay, like we can have x or u is equal to x minus a divided by b, and v will be equal to y minus c divided by d. Okay, here a and b are respectively the origin and the scale factors of x. Same way, c is the origin factor of y and d is the scale factor of y. Okay, so now in this case what happens is the correlation coefficient of x and comma y is denoted by r of x comma y, right, or rxy, and the correlation coefficient of u and v is denoted by r of uv. Okay, so let us understand x and y, the correlation coefficient is r of xy. Okay, now the correlation coefficient between u and v is defined by, it is dependent upon the sign of the scale factors. Okay, b and d are the scale factors. See, look, this b and d are the scale factors of x and y. Okay, so r of uv will be equal to b into d divided by modulus of b into modulus of d. Okay, the value of this particular quantity will be either plus 1 or minus 1, because b and b will get cancelled. Other than the sign of the of b. Same way d and d will get cancelled other than the sign of t. Okay, so that's it. So now this times r of xy. Okay, r of uv will be equal to b into d divided by modulus of b into modulus of d into r of xy. Okay, r xy, correlation coefficient between x and y. Okay, this is a very important formula which you need to remember. Okay, there is one more way of expressing this. Okay, so x can be written as bu plus a, or we can say that x is equal to a plus bu, and y is equal to c plus d into u. Okay, in that case b will be the coefficient of u. B is the coefficient of u. Okay, b is the coefficient of u by taking coefficient of x as 1. Okay, x equal to something, when you express the expression as x equal to something, then b will be the coefficient of u, and d will be the coefficient of v. Sorry, here it should be v. Okay, it is v. Now that's, so we can modify this thing. Now we can modify this thing in a different way. We can understand this thing and write this thing in a different way. As we said, the value of b into d divided by mod b into mod d could be either positive one or negative one, right? So therefore what happens is that this r of xy, the value of r of xy will be equal, or r of xy will be equal to r of uv. Okay, r of uv will be equal to r of xy if both b and d have the same signs, because if both of them have the same signs, the product will be positive. The numerator will be positive and denominator will be positive. And if both of them are negative, then also the numerator will be positive and the denominator is always positive. So therefore the result will be 1. Okay, so the coefficient of rxy will become 1 in this case if both b and d, okay, have same sign. Same way, r of uv will be equal to minus of negative of r of xy. Okay, the value will be negative of r of xy. Okay, r of uv will be equal to negative of r of xy if both b and d have different sign. Okay, this is what we need to understand. Now we shall understand this thing, or apply this thing in a particular example where we shall understand how the two variables are related to each other. Okay, now let us look at this question. This will give you an idea about the correlation coefficient and how it is dependent upon the scale factors. Okay, how it is dependent upon the sign of the scale factors. Okay, now here the scale factor can be found out. The scale factor can be found out by just, okay, u. Okay, u will be equal to, okay, what is b for this? What is b for this? B can be obtained as minus 2 by 3, minus coefficient of u divided by coefficient of x. Okay, here we want the u to be isolated. Okay, we want u to be isolated. So u can be written as 3x minus 4. Okay, u can be written as minus 3x minus 4. You can divide it by 2 here, divided by 2 here. So we can take this as b. Okay, same way, and this is a. Okay, same way, what we have here is v will be equal to minus 16y minus 11 divided by 4 divided by 4. Okay, so this is your b, and this is your d. Okay, so therefore the correlation coefficient is dependent upon the sign of the scale factors. If both of them are equal, okay, r of xy or r of uv will be equal to r of xy. Why? Because both have the same sign. Sign of B and sign of D are same. So that will be equal to this 0.8. Okay, so 0.8. So same way, let us go for the other problem. Second problem is, see, you need to write this as u is equal to so 3x minus 4, okay, divided by 2 and v becomes minus 16 by 4 into y minus 11 by 4. Here the scale factors have different signs. Okay, here sign of b is different from sign of b is different from sign of d. Okay, sign of b is different from sign of d, correct? So therefore what can we have? We have that r of uv is equal to minus of r of xy. Okay, that is minus of 0.8. The correlation coefficient between x and y is given to us as 0.8. So we have minus 0.8. Okay, next question in this case is u will be equal to, okay, I can isolate u as so 3 by 2 into x minus 4 by 2, and v can be written as 16 by 4 y minus 11 by 4. Okay, so in this case what we have here is b is positive, this is b is positive, and this one is also positive, d is also positive. Both have the same signs. So therefore r of uv will be equal to r of xy. Okay, and that will be equal to 0.8 as given. Okay, the next case which we can discuss is like this. U can be written as minus 3 by 2 into x minus 4 by 2, and v can be written as 16 by 4 into y minus 11 by 4. Okay, we can check this. What we have here is, this is b, this is your b, and this is your d. Okay, this is your d, correct? This is b and this is d. So therefore what we have is r of uv correlation coefficient between u and v will be equal to, see here the b and d have different signs, right? One is negative, one is positive, so both of them have different signs. So therefore the correlation coefficient also will have opposite signs, r of xy, and that is equal to minus of 0.8. That's it. This is the only type of problem that can come from the properties of Karl Pearson's correlation coefficient. Okay, these type of problems, these 4 types, the equations may be different. Okay, so change in scale and change in origin. Now we shall discuss Spearman's rank correlation coefficient. Okay, it is used in the case of qualitative data. Okay, Karl Pearson's product moment correlation was used in the case of quantitative data, but Spearman's rank correlation coefficient will be used and applied where we are dealing with the qualitative data. Okay, so let us start the topic. So situations where the data cannot be measured quantitatively, okay, where the data cannot be measured quantitatively, but a qualitative assessment is possible. For example, in the case of a beauty contest, or if you want to evaluate the honesty of a person, in this case, it depends upon the rank of the person, how he is ranked in the minds of people, okay, of the judges, okay, and on that basis, the person is given the rank as 1, 2, and so on. Okay, so this is how it happens. Next, this is what we discussed. Okay, now when we need to find the correlation between 2 qualitative characteristics, for example, beauty and intelligence, how can you connect beauty and intelligence? Karl Pearson's correlation coefficient cannot do this. So therefore now here, because beauty is also based on the rank and intelligence is also based on the rank. Okay, so therefore beauty and intelligence are 2 qualitative characteristics, and when you want to connect these 2 qualitative characteristics and make a decision between them, So in that case, we will be using Spearman's rank correlation coefficient. Okay, so therefore we shall be using Spearman's rank correlation coefficient. So rank correlation coefficient can also be applied to find level of agreement, between two judges, okay, to assess a qualitative characteristic. Now, it is also used in the case of qualitative data. So that's it. All things imply the same thing, that it is based on a qualitative assessment. Okay. Now, next thing is how to find the Spearman's rank correlation coefficient. There are two cases. First, when the ranks are not tied and when the ranks are tied. Okay, the first case is when there is no tie between any of the ranks in a particular variable. Okay, so when the values of the variable are different in the same series. Okay, different in the same series. Say for example, the two variables are say x. Okay, x and y. Okay, I'll take the other one. The two variables are say x and y. Okay, these are the two judges evaluating say 5 people A, B, C, D and E. Okay, there are 5 candidates A, B, C, D and E. Okay, and there are 2 judges X and Y. Okay, so for candidate A, the score given by judge X will be say for the rank given by the rank given by judge X is given by maybe say this is the second rank, this is the first rank, this is the third rank, same way this is the fifth rank and this is the fourth rank. Okay, these are how the ranks were given by the judge X. Okay, now the judge Y has given ranks to A, B, C, D and E as follows. Say this was the first rank, this was the second rank, this was the fourth rank and this was the fifth rank and this was the third rank. Okay, now what we do here is, here we observe that the values of the variables, the ranks given to each variable is different. Rank given to A is different from rank given to B, C, D or E. So likewise, in the same variable, there is no tie in any rank. For example, no rank is repeating more than once. Okay, so that is what we mean by the values of variable are different in the same series. Okay, so no two people have the same rank assigned by the same judge. Okay, so therefore we will be using this formula RR, where capital R represents the rank and small r represents the correlation coefficient. Okay, so rank correlation coefficient is represented by RR, small r suffix capital R, that is equal to 1 minus 6 into sigma di square divided by n into n square minus 1. What is di square? Di square is where di is the difference in the ranks. Okay, di is the xi minus yi. Here what we have is xi. This x is the rank given by, so xi's are the first judge ranks and the yi's are the second judge ranks. Okay, so we need to find out di. Where is di? Di will be equal to xi minus yi. Difference in the ranks. Here the difference in the rank is 0. Here the difference in the rank is 3, and we will be taking the positive difference only, not the negative difference. The difference is 3 in this case, the difference is 2 in this case, difference is 0, and here the difference is 1. Okay, now, or if you apply the xi minus yi, purely xi minus yi, then this will be minus, this will be plus, and this will be plus. Okay, so when you see that the sum of deviations, sum of differences, if you take it in the same direction, xi minus yi, if you take it in the same direction, then the sum of the differences will always be equal to 0. That is a property. Okay, and n represents the number of pairs, okay, or number of candidates. Here this is one pair of xy, here this is a second pair of xy, here the third pair of xy, fourth pair of xy, and fifth pair of xy. So in this case we have n is equal to 5. Okay, and then finally the square of this di, that is di square will be calculated here. This is 0 and this is 3 3 and 9. Okay, and then 2 square is 4, and we have 0 again here, and 1 square is 1. Okay, and we need to find out the sum of the di squares. So this is 9, 10 plus 4 is 14. Okay, this is sigma di square. So this value is placed here. This value is placed here. Okay, the ranks are calculated first of all. The ranks are calculated, and then the sum of the differences, the sum of squares of differences between the ranks are calculated. Okay, and then what we do is put it into this formula. N is equal to 5 in this case. Okay, so 1 minus 6 into sigma di square divided by n into n square minus 1. Okay, capital R represents rank, small r represents the rank correlation coefficient. R represents the rank correlation coefficient. It lies between minus 1 and 1. Okay, n represents the number of individual rank. Now we shall consider the second case. Okay, here in the second case, what we observe is that if there is a tie between the variables in the same series, okay, when the values of the variable are repeated in the same series, or we have repeated ranks, a particular rank is repeated more than once, then which formula to use and how to calculate the rank correlation coefficient, and the formula is given in this case in this way. Okay. The coefficient of correlation RR is given by 1 minus 6 into sigma di square plus sigma over j tj cube minus tj divided by 12 whole divided by n into n square minus 1. Okay, you can just look at this formula, and this is the formula which will be used. Okay, this formula will be used where tj is the jth tie length. Okay, length of a tie. Okay, tie means a repeated rank. Tie means if there is a repeated rank, we say there is a tie between two people. Okay, we shall understand this through an example. Okay, let us consider the following problem. Say suppose we need to calculate the rank correlation coefficient in case of two variables. Okay, that is x and y. This is x, maths is taken as x, and statistics is taken as y, and therefore we can calculate the rank correlation coefficient RR between the two variables x and y. Okay, so how to do this? Okay, first thing, we should assign the ranks to the values or the scores. These are the scores, and to each score or to the marks we need to assign the rank. So highest one will be given the first rank, the next the next one will be given the second rank, and so on. If there is a repeated rank, okay, we will see that. Okay, say 50 is the highest value, so we will be giving first rank to this. Then we have 30 as the second rank. Okay, then we have the third rank to 20, and this one also will be having the same rank, third. So there are now 1, 2, 3, 4 people occupying 4 positions. Okay, now the fourth rank will not be given to anybody, but the fourth and the third rank will be equally shared between the two people who scored 20 and 20. So we will be taking the average of 3 and 4. Okay, because the third rank and the fourth rank are shared between the two people, or they have been tied up. So therefore we will be giving 3.5 to both of them. Okay, and then finally the fourth rank will not be given to anybody, and the third rank will also be not given to anybody, and therefore the average of the tied rank will be given to both of them. Okay, so here this is 10, and that will be the fifth rank. Okay, same way we shall proceed for yi's. The highest one in yi will be yi is equal to 35. So this person will get the first rank. Then we have 30 as the highest. So this value, this 30 and this 30 are tied up. Okay, so the second rank and the third rank are tied. So the average of the second and the third will be 2.5. So this 30 will also receive 2.5 as the rank, and this will also be 2.5. Okay, because the second and the third position are shared. So average of the second and the third position will be given to both of them. Okay, so now 25 is the fourth rank. Okay, not the third rank will not be given to anybody. One person, second person, third person, done. Now the fourth person will be given the fourth rank, and the fifth person will be given the fifth rank. Okay, that is how we give ranks. Now as usual, once we have the values xi, yi's, we will be calculating our di square. Okay, and then finally sigma di square. Okay, let us see. 5 minus 5 is equal to 0. 3.5 minus 4 is equal to minus 0.5, and 2 minus 2.5 is again minus 0.5. What we have here is 3.5 minus 2.52. 3.5 minus 2.5 is 1. This is 0. Okay. Now we should observe that the sum of deviations, sum of difference between the ranks should be equal to 0. Okay. Sigma di should be equal to 0 always. Otherwise, we may have made some mistake anywhere. Now we need to take the squares of these values. This is 0. This is 0.25. This is also 0.25, and then we have 1 here and 0 here. Now we need sigma di square, because we know, as in the formula, we need the value sigma di square. Okay. And then we need a tie length. For each tie, we will calculate the tie length in each series. Okay. That is, first we will calculate sigma di square. This is sigma di square, and that will be equal to 1.5. Okay. This is 1.5. Sigma di square is 1.5. Now we have sigma di square. Now what is the tie length? What is the tie length? We will be adding that value. Okay. Let us see what we are going to do. Okay. So this is RR. We will put it into this formula. We shall put that into this formula and calculate the value. Okay. For each j. Okay. For each tie. The first tie is this, and the tie length is 2. And here again there is a tie, and the tie length is 2. Okay. So we will be having 2 minus 2 cube minus 2. Okay. We will calculate and write. Okay. So look here. This is equal to 1 minus 6 into big bracket sigma di square. What is sigma di square? 1.5. So it is 1.5 plus 1.5 plus 6. See, sum of all ties. What is a TJ? TJ is, in this case, okay, there is one tie here. There is, the tie length is 2. There are 2 people having the same rank. Okay, so therefore there are 2 people having the same rank. So there is a tie where the length is 2. Here there is another tie where the length is again 2. Okay, we should understand that. For each tie, we will calculate the tie length, and that is our TJ. And we will put that into the formula for each tie. Okay. So for this tie 3.5, we have the tie length as 2. Okay. So we will be having 2 cube minus 2 divided by 12. Okay. Plus again for this tie we will be having 2 cube minus 2 divided by 12. Okay. The whole divided by n into n square minus n. What is n? N is the number of pairs. 1, 2, 3, 4 and 5. Okay. So we have 5 into 5 square minus 1. Now once we calculate this value, what we get will be the rank correlation coefficient. Okay. So this can be calculated as, so this is RR will be equal to 1 minus 6 into we can say this is 1.5 plus, so this is 8, 2 cube is 8, 8 minus 2 is 6, 6 by 12 is 1.5, sorry 0.5, 6 by 12 is 1 by 2, 1 by 2 is 0.5, okay, 0.5 plus again 0.5, okay, divided by 5 into this is 5 is 25, 25 minus 1 is 24. Okay, we have 24 here. So finally this becomes 1 minus 6 into this is 1.5 plus 1, that is equal to 2.5 whole divided by 25, 5 into 24. 5 into 24 is 120. So when we calculate this thing, okay, 6 2s are 12, so we have 20 here. So 25 by 20. So that is 1 minus, this is 25 by 200. Okay, 25 by 200, that is equal to 25 1 minus, okay, 5 5s are 25, 5 5s are 25, 5 4s are 20, okay, or 25 into 8 we can take it as 25 into 8, okay, 1 minus 1 by 8, 1 minus 1 by 8, what is 1 minus 1 by 8? 1 minus 1 by 8 is 7 by 8, that is equal to 7 by 8, okay. What is 7 by 8? When we calculate, we get 0.875 using the calculator, okay. So this is the rank correlation coefficient. So there is a strong correlation between the two ranks, okay, between the two marks. That's it. So therefore the formula is RR is equal to 1 minus 6 into sigma di square plus sigma over j, where j is the tie length, okay. It's where j will be the count of the number of ties. So there is, so this is one tie, this is another tie. So we need to repeat it that many times. So here there were 2 ties, each of length 2, okay. So therefore we had the 2 steps. So that is the sum. Same way, what is n? N is the number of pairs of observations, okay. So that is what we do when we have tied or repeated ranks, okay. Now Spearman's rank correlation coefficient cannot be used for group frequency distribution, okay. Also that we should observe that the sum of difference of ranks is always equal to 0. The sum of difference of ranks will always be equal to 0, okay. Hope you have understood how to calculate the Spearman's rank correlation coefficient. We shall meet in the next video.